welcome to part 3 of our Shift Remote Conference, where we bring to you some of the brightest minds together online to share some of their best ideas in this space. Today, we're talking all about JavaScript, and that's why you're here, to find out a little bit more. Just to run through how this is going to work, I'll be your host for today's conference. My name is Bilal, not that you care, and all that means is I'll be popping up every now and then to just introduce the next in our amazing lineup of speakers. Today we have 6 speakers ready for you, ready to share their stories and ready to share their ideas in this space. And how this will work is there is a chat section on the right for you to jump in and write any of your ideas down. Feel free to let us know what you think of the conference as it's going along. We've also got the comment section below where you can engage, where we'll have some space for Q&A. How we structured the day is that we've got about 2.5 hours together. In about an hour's and a half time, we'll have our first break, which won't be too long, but that's your chance to grab yourself a coffee, get yourself a drink, and then get back in front of your screen as we carry on with our day. Please, as ever, use the hashtag ShiftRemote. Tag us on social media. Let us know what you think. Let us know how you're feeling. Let us know what you're doing. Take a photo, take a selfie. Why not? We love it when you do that here for us at Shift. Before we get started, I'd love to say a few thanks though. Thanks to our sponsors, mostly our team at Microsoft and InfoBip, also the team at Autodesk, Microblink, Barrage, Azure Idea, ICT, Japania, Venture, Pseudocode 5, Ars Futura, Nanobit, Infinuum and Q, the team at 9 Dots, Get by Bus, Aspira, Code Anywhere, Pluggy and Netokraja. Thank you so much. Without you, none of this would be possible. So to get us started then, I would love to introduce the man behind this all, Ivan Borazin.
Hi everyone, and welcome to event 3 of Shift Remote. This event is our 3rd event, but is our 2nd this week. And do not forget, we have 2 more coming up next week. So a lot of content, a lot of speakers, a lot of things to learn. This event is on the subject of JavaScript. This is one of my favorite subjects, so I do hope you enjoy it. We have an amazing set of speakers: Martin, Jennifer, Luciano, great friend of mine, and among others. So please do stay tuned. Ask them questions in the chat. These are like amazing people that have a lot to share with you during this event. Also, do not forget our in-person event, Shift Dev, happening in just over 2 months in the sunny, beautiful Split, Croatia. If you can make it over, please do get your tickets, as there are not many left. And that's about it from me. I hope you enjoy the show, and you'll see me in just a couple of days again. Bye now.
Thank you so much, Ivan. And with that out of the way, that brings us on to the start of our conference. And it's time to introduce our first speaker, who's a developer advocate at Google's Search Relations team, who strives to help web developers with building successful, discoverable, and performant web content, as well as various open source projects to keep the web a vibrant and exciting platform for everyone. Let's introduce Martin Split.
All right. Hi, everyone. How is everyone doing? I hope you are having a good time and that you are safe and healthy, and everything is fine as far as fine as possible in this world. I'm super excited to be here and talk to you about a topic that specifically developers are usually missing out a little bit on, and that's fine because, I mean, as developers, we have a lot of stuff on our plate. There's like mobile performance, there's mobile designs, there's content first, there's user first, there's everything first. So some things just get a little lost. But I am here to talk to you about technical SEO from my perspective, which is a developer's perspective. I have been building websites for plenty of years, I think like 15 years by now. I've seen the web shift from desktop to mobile. I've seen a lot of stuff, and I'm now here to talk to you about a thing that I think kind of makes sense to talk about, because we don't want to lose the impact. What is SEO and what is technical SEO specifically? That's something that we're going to be talking about today pretty much for the next 15 minutes. SEO stands for search engine optimization. That's the short version of it. What does that mean? What does it do? How do you do it? When I ask that question, especially to fellow developers, I oftentimes get a response that is either like, you basically sacrifice a chicken and wait for full moon, and then magically the right things happen, to, oh, you just like, it's all weird stuff and you buy links and then you're done. It's not really that. It is quite a bit of a larger topic, such as how do you do software development? That depends on what you're building and what the team is that you're working with, what the product or services you're trying to offer, similar to SEO. But fundamentally, what search engines do is, as a developer, I want you to think of search engines as an API. Not a really great API, because the documentation is a little questionable, like shaky, because we can't document everything. We can't really give you the algorithm, because then people would game the algorithm. But roughly what it does is, it's an API that consumes your website and then presents it to users who look for what you're offering, hopefully. And roughly what you have to do as a search engine, if you want to do that, is the first step, you have to crawl. You have to have a piece of program, a piece of code that makes an HTTP request to your website and then gets the HTML back and then looks at what it is. When it looks at what it is, that's usually the indexing stage. It basically tries to figure out, what is this website about? What can people find here? What can people do on this website? Is this website about cats? Is this website about boats? Is this website a social network? Is this website a website about photos? What is this? That's the indexing stage. We understand what your website is about. HTML helps with that. It's, if you're doing it right, more or less semantic. And then we have a list, we have like a library basically of lots of websites about all sorts of topics. And for each topic, we have lots of websites too. So if your website is about cat pictures, there's lots of cat picture websites. Or if your website is about nutritional ideas for cats with allergies or something like that, that's a very specific thing. There's only maybe like 100 or 1,000 websites, but it's still a lot. And now we have to present these websites that we know for this topic in a list. So we have to order them. This is called ranking. We have to figure out what we think the best website for the user looking for it. And ranking is a very tricky topic because it depends on lots of things. So for instance, if I'm searching for cafe and I'm in Zurich, I want the search engine to show me cafes in Zurich, not cafes in Istanbul or in St. Petersburg, because these cafes are probably not very useful for me at the time. But if I am in St. Petersburg or Berlin or Moscow, then I want to see cafes there rather than in Zurich, because that's not helping us either. So ranking is quite a tricky science, and lots of algorithms are involved with ranking, but I will not talk about ranking much today. And once we have this list, we now have the ranking, we have the top 10, and then the top 20, and then the top 30 websites for the query that you asked the search engine. We have to serve these. Now, serving is something that is our problem. Ranking is something that is our problem. So I would say, as developers, we have a lot of influence over how the search engine interacts with my server and how my server responds to the search engine, as well as we have content control. So we know what is our website, and we can make sure that our technology is working well so that the content is presented in the best possible way. Ranking, that's just like dragons, basically. So there's like hundreds of factors. We don't really have influence over that. And also, if our website is fantastic, but tomorrow a better website appears, this website might overtake us in rankings. We haven't done anything wrong. It's just someone else has stepped up the game. So we don't really have control over that either. And as I said, serving is entirely our problem. That's not your business. That's fine. You can just trust us to give people your website if it's good for the search. And this is free traffic. And we found that roughly, excuse me, roughly 50% of the traffic on most websites is organic search traffic, is people searching something. Because think about it. If I'm looking for something, anything really, I usually go to the search engine of my choice and then type in a query and then click on things that I'm being shown. You want people that look for what you are offering to see this and click on your search results. So this all aligns if you think about it. You are building a fantastic website with great content on a specific topic, and you want that potential new users who don't know about your website find your website through a search engine. And that's legit. That's reasonable, right? You get new users through search engines. And we as a search engine, as Google Search, if your website is really good for the users, we want to show this website to the users looking for whatever you're offering. So these are basically like we're going in the same direction with what we are trying to achieve. You want to have a good website for users, and you want these new users to find your website. We want your website to be visible to users that are then happy when they click on you. And SEO is kind of like the middle bit. A good SEO helps you to understand what people are looking for and make your content appeal to them, as well as making sure that your technology stack is in shape for search engines to be able to actually consume your content and index it and highlight it the right way. So if you are working with a good SEO, they help you bridge these two parties, search engines and your side of development, and make sure that everything goes in the same direction and everything is a smooth ride. Now, let me give you an example of why this is important and why it's not just technical SEO. Technical SEO is one part of this bigger topic. I'll give you an example. My toaster broke, I need a new toaster, so I go to the website that I find in a search engine. If this website looks like this, that's not a good website. I'm looking for a toaster, I look at this website, I'm like, the picture might be a toaster, but I'm not sure. And then I read what's on the website, and it says smart, simple, beautiful, which means nothing. Sounds very fancy, but means nothing. This could be about watches, this could be about cars, this could be about boats, this could be about pretty much anything. This is not toaster specific. It will disrupt your breakfast, no thanks. Thermochemical food processing, what does that even mean? The best invention since sliced bread. Well, this website isn't telling me much. The links, home, our philosophy, hot bread X10, join the movement, none of this is what I'm looking for. So no matter what framework this website is using, how fast this is being served, if it's mobile friendly, how nice the design looks, this is not a good website for me as a human going to look for a toaster, because I don't even know if this is about toasters. If it is about toasters, it doesn't really tell me much. If I want to find more information, I don't want philosophy and I don't want to join a movement, so this is not good. And watch this. Watch the screen closely. Same design, same framework, same fast internet, fast web performance. It loads in like under a second. Everything's fantastic. Does code splitting, whatever, uses Webpack, doesn't matter. The content has changed. That's the only thing that is different. The only thing is what is on the page. The fastest toaster is the biggest thing on the page. And I'm like, I am looking for a toaster. This is the fastest toaster. Good. I like that. But what if I don't want the fastest toaster? I don't even know how to choose the right toaster. There's a link that says how to choose a toaster, so I can go further on this website. If I don't want to see what kind of toasters they have, if I'm like, I want the cheapest toaster, then I can click on our toasters. I'm pretty sure they'll have more than just the fastest toaster. And if I want to buy this toaster, there's a little call to action button that says, buy a toaster. Same design, same technology, much better website for my need as a user looking for a toaster. So what I'm trying to say here is, it doesn't matter how great your technology is, how great you are as a developer, how fantastic your server responds to everything and how fast everything is that you're using CDN, whatever. If your content isn't good, you'll have a bad time. Because if you are doing technical SEO without looking at what do people look for, then you are basically polishing a turd. It's going to be a very polished turd in the end, but it's not going to be great. And then people are like, oh, search engines are weird. No, you have to think from the user's perspective. That's why if you don't want to do that, I understand that. I, as a developer, don't want to like write the content on my website. That's what I hire people for who know this better. Content writers, fantastic. User experience and information architecture folks, fantastic. Be aware that technical SEO is not everything you need to do. It's not a checklist that you can check like, okay, my website is fast, my website is mobile friendly, my website uses the latest technology, done. Now I'll be like on the first position in search engines. It doesn't work like that. Okay, now I promised you technical SEO, so let's do that. That's the more interesting thing for us because that's what we as developers have under control, right? First things first, search engines, when they crawl, they go to URLs. So we need a URL. If a piece of content does not have a URL, search crawlers won't find it. These two URLs are looking quite similar, but they are quite different. The first one is just going to a specific document, in this case, a folder and traditional -URL on this host. The second one is a URL for a piece of content. So you have lots of content on the page, and you want to address this specific piece. Page hash subsection. Imagine a long Wikipedia article. If you want to go to the history section in this very long Wikipedia article, you can do like hash history, and then you go to there. Search engines don't care. Why do they not care? Because we only care about the whole document. So we kind of ignore this fragment, which is problematic if you are using fragments to actually cheat. When single-page applications came around at first, we needed a way to kind of like use JavaScript to influence the way that we navigate between pages so that the browser doesn't actually kick off a navigation. So we used hash fragments. When the fragment changes from hash about, in this case, to hash products, our JavaScript would load different content. But if search engines are ignoring this hash part, then all they see is example.com, example.com. So they only go to example.com, to this one URL, and only see whatever is there on the first load. So you would hide a lot of content from the search engine. So if the search engine doesn't see it, it can't show up in search results. Not great. What can we do instead if we want to build single-page applications? Because single-page applications are great. Well, in that case, please use the history API and configure your server to handle these URLs properly. Because now we have /home, /about, /products. And each of these URLs will be crawled and can be found and can be crawled. And then we can show this content under these URLs properly in search results. Unfortunately, we found in 2019, when we crawled lots of websites, that 12% of the pages that we analyzed and were single-page application pages, they used fragment URLs to navigate. You want to reconsider that if you want to highlight all this content to search engines. If they are behind a login, it doesn't really matter because Googlebot will not log in. But if it's content that you want to show up in search, then you definitely want to make sure that you're not using fragment URLs to change different content. You can use fragments to navigate within the page, absolutely fine, but don't abuse them to load different content. I can't believe that I have to say this, but links are kind of important because what we're doing is Googlebot doesn't click on things. Googlebot looks for links and URLs in these links. These are fantastic links. The first one is a very plain old link. It goes to a URL, all cool. The second one does some JavaScript stuff that maybe doesn't like reload on the page. That's fine. That's perfectly fine because there's still an href. It still has a URL. This isn't great. This link doesn't go anywhere. It only responds to a click, but Googlebot doesn't click. Googlebot needs a URL to crawl. We can't make an HTTP request to go to stuff. It doesn't work, right? The other thing is that's also not helping. That doesn't go anywhere still. So we can't really do a crawl here. Also, that's not a URL that we can make an HTTP request to, so that's not good either. And yeah, as I said, this is not even a link. That's a button. Don't do this. And that's like the worst thing you can do. That's not even an interactive element. You are making this interactive, but why? Just use a link, god damn it. So just don't use any of these things. Just stick to normal links. You might be laughing now. If you are, good on you. That's fantastic. That means that you got this right. So many people got this wrong. So many people. It's amazing. And then people say, like, okay, but if it makes an HTTP request and gets the HTML from that, what about single-page applications that do client-side rendering? There's no content here. Will Googlebot not see the content? Googlebot will see the content. That's not a problem. We are rendering every page. Every page that we are seeing goes through a headless Chromium and then actually produces the full HTML after JavaScript execution, and we are using that to index. So you don't have to worry about client-side rendering or client-side JavaScript that much. Queue time, oftentimes SEOs are like, oh yeah, but there's like 2 waves. No, there's not 2 waves anymore. Oh, but there's like a long queue time. No, at median, it's 5 seconds. The 90th percentile is within minutes. So you don't have to worry about queue time as well. Currently, Googlebot renders with Chrome E03, but whenever there's a new update for the stable Chrome, we are updating our Googlebot, and you can tell that from the user agent. All the testing tools that we have available for you are using the same renderer. We do support web components. That's fine. But what happens if you have some light DOM content and some shadow DOM content? Well, in this case, we kind of go with what the shadow DOM produces. And that means that you want to make sure that you're projecting your light DOM content into shadow DOM if necessary. You can use slot elements. You can copy things over. You can move things from the light DOM into shadow DOM. That's fine. But in the end, you want to make sure that you have a way to produce rendered HTML that contains your light DOM content in some way in the shadow DOM. Lazy loading is fantastic. It's now natively available in Chrome. We support that by default as well for Google Search. And we just want to make sure that you are aware that this exists. It's a very low-hanging fruit. It's great. If you can't do that, or if you want to lazy load on things other than images and iframes, we recommend using the intersection observer because Googlebot doesn't really scroll, but we have ways of dealing with intersection observers. if things go wrong in the client-side rendered single-page apps, that's usually looking something like this. There is something on the search results that you don't want. Those are soft errors. They happen quite quickly. Imagine you go on a website with a URL that doesn't exist. The server doesn't know this. It's a client-side rendered single-page app. The JavaScript code basically is loaded after the server responds. The server responded with 200, but then the page shows error content because JavaScript decided this is an error. That doesn't help us. It would be a lot better. So like, this is the problem, right? It makes the server says 200, okay. The JavaScript goes like, let me fetch this content. Oh, I can't, there's an error. Then we show an error message. It's not very easy for us to spot these things. We are pretty good at it. We might find the soft 404 and then not show it in search, but sometimes it slips through. A better way of doing that is to configure your server to have a URL where you definitely respond with, let's say, in this case, 404, and then you use JavaScript to redirect, because then we render the page, we get redirected, we see, oh, so this page redirects there, and this page is a 404, so the other page is also a 404 pretty much. That is good to avoid problems. If you want to learn more, I don't really have that much time. I just wanted to give you a quick insight over the most common errors that we see. There's a video series that tells you more about this, and you can also check out our guides that have much more information and much more common problems that people run into if you want to learn more. Do test your pages. We have great tools like the mobile-friendly tool that shows you the rendered HTML for any page. Search Console shows you everything for the whole site. And yeah, just go and try out these tools. They help you figure out how Google Search sees your pages and if there are any problems. And with that, I'd like to say thank you very, very much. Have a fantastic time. And I'm now here for questions on the YouTube channel. So if you were using, I think it's there, the chat, you can ask me questions and I'll happily answer them.
Okay, thank you so much for that, Martin. And moving on with our conference, our next speaker, when I started reading this bio, I thought, now my niece and my little cousin, they would love this because it's got the word TikTok in it, and all I could imagine was them dancing. Our next speaker is a Google developer expert and a cloud developer advocate lead at Microsoft on the academic team. They have over 20 years experience as a web and mobile developer, specializing in cross-platform mobile and web apps. With a PhD in medieval literature, their area of focus is currently in applied machine learning. Let's give a warm welcome to our next speaker, Jen Looper.
Hey everyone, how are you doing this morning? I'm calling in from Boston, Massachusetts in the US, and I'm so proud and pleased to be able to speak to you online today. So today we're going to talk about an app that I built, one of those very useful apps that will definitely make me a lot of money. It's PoseDance. It's a TikTok trainer, and I hope you enjoy this talk. My name is Jen Looper. You can always find me on Twitter at Jen Looper. I'm a cloud advocate lead at Microsoft on the academic team. So if you're a student or an educator and you like hanging out with cool people, hit me up online. I'm always on Twitter. Okay. So let's see. Why is my screen not going? Alrighty. Let's try it again. Okay. I'll just go like this to make it a little bit bigger. Since things are not happening nicely according to my keyboard. That's okay. We'll just do it like this. Okay, so what we're going to cover today is a little overview of what is TikTok. I want to talk about PoseNet. What is PoseNet? And then we're going to dig deeper. We're going to go ahead and talk about how I built this app called PoseDance. And then we're going to do the demo. So this is very embarrassing. So I hope you won't be too judgmental. Okay. So what is TikTok? Well, TikTok obviously is the greatest mobile app. It's an app that evolved from Musical.ly, which was an app that was built for kids to build music videos all together on. And yes, it is a complete waste of time. I think we are in the process of having it banned in many countries, and one of those might be in the US. So folks, enjoy TikTok while you can. So we'll see what happens. Okay, we have, oh yes, I just wanted to mention something, background noise. Okay, so yes, TikTok is a little bit like Vine, if you enjoyed Vine. It's little short videos, and it's famous for dances. There's an article at the bottom of these slides, which I have shared elsewhere, and it's on the Rolling Stone talking about how I spent a week on TikTok and only lost a week of my time on TikTok. So I hope you enjoy it as much as I do. It's awesome. Okay, so let's talk about what is PoseNet. PoseNet is pose detection in the browser, and it uses TensorFlow.js in the back, so it can be used on the web. And it can be used with your webcam, with video within Canvas, or it can be used for analyzing still pics. And it basically creates a skeleton on top of the video that you're displaying, or on top of your webcam. It can be used to display either one or two people. And interestingly, it's being used to analyze sports. For example, if you are injured in a sports incident, you're sliding into first, for example, to use American baseball as an example, you might be able to have a video clip and run a skeleton on top of it using PoseNet to figure out exactly at what moment your ankle twisted and you had that accident. So, and maybe help you correct those issues. I think it would be a great app, a great technique to use when analyzing yoga or when learning yoga poses or dance poses, as I tried to do here. And what it does is it just analyzes these videos for you and gives estimations using machine learning of where it's determining in each frame the position of 17 key body points. And it's your job actually to create the skeleton on top of it. It's just going to return to you the points. And it looks like this. So the position here is it's giving you X and Y coordinates or Cartesian coordinates of your position of what it says it believes is the left eye, and then the right eye, and 17 body parts. So it's 5 parts of the face: shoulders, elbows, wrists, hip, knees, and ankles. So those are the 17 coordinates it's going to return, and it gives you a score or a certainty that it believes it can find of these coordinates. So when I'm dealing with looking at using machine learning models in apps, I'm very interested in applied machine learning, so where these things, how they can be used within apps. But I think that it's always a bit dangerous to just use these things ad hoc, to just slap them into an app and hope for the best. I like to dig a little bit deeper. So let's talk a bit about what's going on under the hood. So PoseNet is built on the shoulder of a giant, which is PersonLab models. And PersonLab is a way of determining people's stances and actions in a video or a photo. So previously, you could determine where people are positioned in a photo or a video just by using bounding boxes. And PersonLab allowed you to figure out to not just use bounding boxes, which is a top-down model, but it's a bottoms-up, it's a part-first box-free model using fully convolutional determination. It predicts relative positions of those 17 key points. And it starts from the most confident detection and works itself up based on trained body poses. And there are some links in this talk, which you can find on my GitHub, to some research papers that talk a little bit more about PoseNet and PersonLab. So digging even a little bit deeper, we can figure out how PersonLab was built, essentially. And it's interesting. PersonLab training consists of 2 steps. So it detects a person, and then it estimates the poses. First, it attempts to detect the key points, and then it groups those into person instances. And the network is actually trained in a supervised fashion, looking for 17 face and body parts using the COCO dataset. COCO is Common Objects in Context, COCO dataset. So it's a whole bunch of images of people. And what it's doing first is it's using heat maps and short-range offset predictions to identify possible key points. And you can see how it's working on creating these heat maps. And then it uses a technique called Huff voting to determine the most precise placement of a key point. So from those votes, creating the Huff arrays alongside mid-range offsets between determined key points to detect human poses. So it creates the heat maps, and then it uses the arrays to figure out the offsets. And you might be interested in what Huff votes and Huff arrays are all about. So they're based on the Huff transform algorithm, which is a feature extraction technique used in image analysis and computer vision. And it's designed to find imperfect instances of objects within a certain class of shapes by means of a voting procedure. So it's a little bit interesting thing to kind of look at these research papers and figure out what's going on behind the scenes. And very interestingly, Huff transforms were invented in 1959 when they started getting serious about looking at images from a machine learning viewpoint. And I think it was actually patented in 1962. So these things have been around a long time. And I think it's really interesting to think about how all of this fancy new stuff we're doing with machine learning, we truly are building on the shoulders of giants, and some of these giants are kind of old. But it's still awesome to use. So anyway, with the voting, it uses detections to create likely instances of individual people using these long-range offsets to group the person into segmented instances of each person in an image. And all of these steps use convolutional neural networks. So really, it's building on, it's using this algorithm and this technique to figure out groupings of key points and to figure out which one of those belongs to an individual person. Very interesting and kind of innovative type of use case. So Person Lab is used by PoseNet, and PoseNet is a project of Google Creative Labs. And what it's doing is it's running real-time pose estimation in the browser. And PoseNet allows us to abstract away the complexities of the model. It encapsulates the functionality into easy-to-use methods. And fortunately for us web developers, it's installable now via NPM as part of the TensorFlow models repo. And it accompanies TensorFlow.js. You need to have the models and TensorFlow.js installed into your app so that you can use TensorFlow models in your browser. And fun fact, it uses fast, greedy decoding algorithm from the Person Lab paper. So it really is building on this really interesting technique. So we know what we're going to do. We're going to use this technique and this model to go ahead and build an app. And we're going to use PoseNet to compare a dancer's movements to your own, comparing the TikTok video to your webcam output. So that's really interesting. I mean, why not, right? You could actually make something useful, or you could make something like this. So why not? Let's just go ahead and compare some TikTok videos. And interestingly, on the TikTok mobile app, you can actually download individual videos if the author has given you permission. So I went ahead and used those downloaded MP4s and implemented those, inserted those into the app. So we'll talk about the architecture in a little bit. But before I do that, I just wanted to mention that I had a little doubt in my mind as I was building this app. And I started wondering, are PoseNet, is Person Lab, and is the app built on top of the stuff? Is PoseNet, the app, inherently ableist? What is ableism? Ableism is the concept that you might build something, build an app or build a product that only works for people who are have standard abled bodies. So it might have a problem working for someone, who is missing an arm, who is missing a leg, or missing an eye. I was worried about that, but it's interesting to use PoseNet on top of differently abled people's images, because what it doesn't make any kind of judgments. It just measures. If it doesn't find an elbow, it just doesn't display that. But I wanted to make sure not to create an ableist app by working with TikTok videos that are using that are differently abled. So I didn't want to only show semi-professional abled dancers, because that actually would be perhaps perceived as ableist. So I wanted to make sure to create an inclusive app. I made the effort to find all kinds of dancers. And the cool thing is, on TikTok, there are all kinds of dancers, folks in wheelchairs, paraplegic folks, people with vision and hearing issues. And that's why I always say that TikTok is kind of wholesome, because it really does show the, all of human ability. Okay, so when building Pose Dance, I had a lot of stuff to think about. I had design considerations, how we're going to lay it out, how we're going to use the different videos, and also implement the webcam. Think about the base architecture, how to use PoseNet, how to handle your webcam, and how to handle these models, which are actually pretty heavy loading. How to build scoring and leaderboards, because it's a game after all, and the backend implementation, how to use Azure functions, how to use PlayFab, which is the backend that I used, which is a cool way to store game scores, and how to deploy this thing. So let's talk a little bit about the design and the architecture of the app. I'm a Vue.js developer. I went ahead and used Vue.js. That was an easy choice for me. For me, recently I've been using Bulma a lot, which is a great way to style your app nice and responsive in an easy way. I used Validate, however we pronounce that, to validate the authentication form fields, and Vuex to save my user state. Axios to make calls to the API that I created, and TensorFlow.js plus TensorFlow's PoseNet model, which is all included here. So these are the dependencies of the app. I always like to show my package.json file, as it kind of tells the truth, what's going on in the app. You can't lie, package.json. Okay, so using TikTok in your webcam, I needed to create a side-by-side layout. So I had the MP4s downloaded from TikTok, and then side-by-side, I wanted to show a webcam output. Interestingly, you cannot use TikTok with the embedded code that it wants you to use. So if you go to TikTok on the website, they'll say, if you want to use TikTok in an app, you need to use our embed codes. And it shows a lot of Chrome around the video, and the video is playing with a lot of extra stuff all around it, and credits to the author, and credits to the music that's used. So I couldn't use that because I need to have my videos on a canvas so that I can draw key points and a skeleton on top of them using the Canvas drawing API. So I had to download MP4s out of TikTok. So that's just a little design consideration. And then I play tested this thing a little bit, and I needed to, it turns out that it's better to preview a video and learn the dance before immediately jumping in and getting a score. So that's one little design situation I had to deal with. Also, I wanted to go ahead and use those embeds that TikTok wants you to use because I want to make sure to attribute the video and to attribute the dancer showing the video, and then click into the app, and then you can show the interface side by side. Okay, so here's the real kicker of this app, which is how to use PoseNet. PoseNet modules are big, and I have to use two of them because I have to load up one for the video and one for the webcam. And I have to make sure to wait for the MP4 to load because they're kind of heavy as well. Ensure that the webcam is ready if I need it, so I need to allow for preview mode. So that's another bit of wait time that I have to have. I want to have a little place to encourage you log in because I can only save scores if you log in. And so I have to have a little place for a loader widget to run. So this is all adding weight to your screen. And if you can notice, it's a pretty large amount in the JavaScript heap, and it takes about 7 seconds to 10 seconds to load this thing, which is not optimal. It is not a production-ready app. It's just for fun. So just to let you know that these models are heavy, and handling webcams and videos in general is heavy as well. So when you're doing this, you need to make sure to have your webcam be loaded asynchronously and your videos loaded asynchronously. Async all the way. It's your friend. So just use it. So you need to reference your TikTok video, set up and enable and reference your webcam video, set up 2 canvases to draw your key points and your skeletons, and then load up your models. So this is all happening in your mounted lifecycle hook. It's really a lot going on, and I think I trimmed some stuff out of this just for this code step because it wouldn't fit on the screen. So you're handling video events and then detecting poses when it starts playing, and calculating your score when it's done. So in terms of handling posing, for each of the video, you're going to load up your model, and then you're going to start estimating your pose. So to make sure that I'm able to collect data so that I can create a score, I have to append each pose as its points are coming through per frame to an array to figure out the future scores. And I also need to draw the key points and the skeleton in real time using the estimated location of the key point. And all of this is happening because we have available to us in the browser the request animation frame API, and it's detecting every video keyframe, redrawing and redrawing and redrawing the skeleton, and grabbing the points for your score. So there's really a lot going on, and when you think about it, it's kind of miraculous what browsers allow us to do, to use machine learning right in the browser. Okay, so, oops, sorry, my bad. Drawing a skeleton, yes, drawing a skeleton, okay. So how do we draw a skeleton on a video? Well, you need to gather your adjacent key points, and then you're drawing dots and lines using the Canvas API. Here you can get a little bit creative, so you can create dots with different colors and of different thicknesses, and make and this is the part where you actually are doing the drawing yourself. So you have some creativity, and you're just using the Canvas API within the browser to draw the skeleton. Scoring was the toughest, actually. This was the hardest for me to figure out. And a contributor actually improved it a little bit so you're not constantly in the negative. But what I was trying to do was take the key points from the TikTok video and use that as the basis, the kind of the statement of truth, the actual thing that I'm comparing myself to. So I kind of decremented the score every time my movements on the webcam stray from the movements on the TikTok video. So it's very easy to get very deep into the negative. So we did a little math to make it a little bit less horrendous. Fun fact, I did play test this app with my daughter, and she really hated the way the scoring worked. So I'm glad that it's a little bit less negative now. So all you're doing is you're comparing your webcam points array to the video points array, and you're finding the difference. Sorry, I keep on scrolling. Finding the difference between the two. And yes, it's very easy to degrade to negative. So I'm open for all PRs on PoseNet, and I also created a code tour in the PoseDance repo. So if you're curious about how all the code fits together, you can run a code tour in Visual Studio Code. So that's a fun thing to try. So in the back end, I need to collect those scores and store them somewhere. So I used PlayFab, which is a very fun and free service that is great for games. It's a mobile platform as a service backend that you can use that was acquired by Microsoft. And I put all of the calls to PlayFab in the API folder, which sits separate from my app folder. And it's using Azure Functions to call PlayFab. So this is an example of some code that calls an Azure function. And whenever you're sending a score over to PlayFab, it's going via the API that you build in your Azure function. Now, in a leaderboard, to create a leaderboard, you need to have the secret key, and you can store that in the deployment process that I'm going to show in a second. You need to be logged in, so you need some kind of ability to be logged in and sending scores. But to view the leaderboard, you don't have to be logged in, so that's why you have to have a secret key. And building the leaderboard via the PoseNet API, and you're using Axios to display it. Okay, so last thing I want to show you before doing the demo is how I deployed this. So where is this app going to live at the end of the day? So fortunately for me, and fortunately for every front-end developer out there, we have something amazing that was released, and it's in preview mode right now. It is called Azure Static Web Apps. I strongly encourage you to go to AKAMS/try static web apps. It is really a great solution to be able to deploy your web apps, whether it's in VuePress or Vue or Gatsby or React or Angular or Scully, which is Angular's static web app creation tool. You can go ahead and deploy these right into Azure Static Web Apps. Store your environment variables in the app portal, integrate Azure Functions, and to have a quick and easy deployment, and it's via GitHub Actions. So it's all integrated into Azure and GitHub, and it works really, really well. Very happy about this because prior it wasn't so easy to have static web apps working nicely on. Here we are. We're at the end of code walkthrough. All of this is available on GitHub. So I'm going to show you the app itself. All right, so here we are. This is the app that I created for you. It's called PoseDance, and if you go to AKAMS/PoseDance, you can try this app yourself. Go ahead and log in so that your scores are collected. All of this information is on this video, including a video of this conference. I'm writing a blog post right now, but this GitHub repo has a code tour associated with it, so you can use that right in your. I'm going to go ahead and choose this guy. Now I can do this. Load up, so you can see how long it takes to load. So it's going to load up. Okay, it says it's ready. So I'm going to go ahead, and I hope you can hear the audio, but no guarantees. So if you can't hear the audio, you just have to imagine what's going on. Okay, I'm going to go ahead and press play. Okay, here we go. Okay, what's my score? I feel like I did well. Oh my gosh, I'm still in the negative. I swear I just did this and I was in the positive, but that's okay. You know, we do the best we can with the tools we have. So, okay, that is the end of my presentation. And if you would like to try PoseDance, you can just go to AKAMS PoseDance, and you'll find the app here. You can check it out. Make sure to log in. Let's check the leaderboard. I still haven't bested my own score, so I didn't increment, which is fine. But you can go ahead and try the app. I'm curious about what you think of walking through the repo with code tours. Just see what you think. There's a little bit of a fact here because people have some questions about the implementation. So if you have questions, I'll hop on YouTube and check out your questions. There's slides. The slides are here, and you can learn more about PoseNet here. So lots of things to think about, and I am done. Thank you.
Thank you so much, Jen. Now, as ever, if you have liked the conference so far, let us know in that chat. Let us know what you thought so far about Martin and Jen's speeches. Any thoughts that have come to mind? Any ideas that are currently bubbling there for you? We have one more speaker before we take our break, and this is a short one, so please get involved. They're a self-taught software engineer at 32 years old, working at Barrage for the last 4 years. They consider themselves a full-stack developer with a fear of CSS, working in Node.js and Vue.js. As much as they love working on front-end applications, they mainly focused on the back end. They say that building robust and secure applications in Node.js are the workhorses of many projects and teams that they develop. Let's welcome from Barrage, Tibor Hudic.
Hi, my name is Tibor, and I'm going to show you how to do parallel processing in Node.js. If you have ever written a Node.js application or even heard about Node.js, you probably understand that Node.js runs in a single process. And even though Node.js runs in a single process, it's still very fast and can handle a lot of requests at the same time. But if you decided to do any computationally heavy operations in that single process, your application might experience performance degradations or slow down or even crash. So that's why I created this talk. As I already said, my name is Tibor. I am a senior backend developer at Barrage. I'm also a development group leader, which means that one of my jobs is to lead other developers in building fast and reliable applications for our users. And we achieve that by building tools and frameworks that help us write structured code that will be fast and easy to maintain. So what does parallel processing mean anyway? Well, that's a method where your program is simultaneously splitting its tasks and spreading them across multiple microprocessors. Thereby, it achieves greater performance because a lot of the tasks are happening in parallel. And you can achieve that by running that application on a computer that has multiple processors, or you can even achieve that by spreading that on a computer network. So in JavaScript, there is an option you can use. If you are writing front-end applications, you understand that if you did a lot of computation in them, the application will slow down. It will become laggy. It might even crash and show that ugly screen that application has stopped responding to your users, which is not a great experience. Therefore, you can use WebWorker API. If you have anything that is computationally heavy, you can offload it to the WebWorker. It will tell the browser to fork additional process for your application where all the heavy lifting can happen in the background while your application is simply listening and sending messages to that worker. In Node.js, there is something similar as well. It's called child processes that you can fork out of your main application process. And that is something that works pretty much similar. You give it a script that it will run, and then you communicate the messages through your application and the child process itself. Now, as you can see on the screen, that's the simplest example I found. It's actually the first one I found on Google about forking child processes. And it is something that is very easy to implement, but it can be difficult to maintain in a longer run of your application. So we did not choose to go with this route. We implemented something on our own. We use Redis to be sort of a middleman and state database for our worker queue. Redis is a very fast in-memory database, and it supports a lot of data structures like strings, hashes, lists, sets. Lists are something that we found very interesting for this because lists is sort of like an array. you can push or pop items out of it. And the most important of all, Redis is a database that supports atomic operations, which means that whatever commands you send to it, they will be executed in a sequential order. So how does that actually work? Well, we have a Redis instance, and the important part is all of the dispatchers and the workers need to be connected to the same Redis instance for the queue purposes. So they will connect to that same one, where they will know where the queues are actually stored in form of a list. And once you decide to dispatch a job, you'll give it some payload, and the dispatcher will actually JSON stringify the payload together with the job information and push it onto the queue. One of the workers who is listening to this queue will pop the job, try to instantiate it with the payload you gave it, and will start working on executing them. During that time, the queue and the dispatcher and the workers, it will send Redis pub/sub messages that you can listen to on any instance that has access to this database, and then you can either track progress or monitor the overall queue, what's happening on it. So without much talking, I am gonna try to show you a small demo of how this all works. I have a project set up over here with the latest version of our framework already installed in it. I have prepared an index file that has the framework loaded in it, and it is started. Also, I have prepared a configuration for our queue that is listening on my local host Redis, and I've created a simple function listen that actually subscribes to the Redis pub/sub and is listening to the messages that the queue is sending. This will simply help us to visualize what's happening. So I'm gonna start by creating a job. And also command. All right, so these commands come integrated with our Felony framework that helps the developers build fast applications with structures that they should follow in order to make the applications easier to maintain later. So I'm going to start with the command that will have an empty array where we will push all the jobs before we send them onto the queue. And we will create 100 jobs. So jobs, and I'm going to push the example job. I'm going to give it empty payload, and it's going to go on example queue, for example. All right. So I have to do batch dispatch of those jobs onto the queue. This will use Redis multi-commands, which will dispatch them all at once. And I'm going to import the listen function. All right, and I'm going to listen on example queue, and I'm going to expect 100 of jobs. All right, so I'm going to edit the job. So this is the boilerplate of our job. The handle method is the thing that is actually going to execute once we instantiate this job, actually once the queue worker instantiates this job. And in case the job fails, we also have a retry strategy that will decide if we're going to retry it or just give up on it. So I'm going to return new promise. And I'm going to simply set timeout of 100 milliseconds. Also, I will set the instance of this queue worker This is something we will pass from the arguments once we start the queue worker, and whatever gets on the payload will actually be sent with the job through Redis pub sub messages. So I believe that's it. This will actually be used so we can have a nice display to see what's happening. All we have to do now is start our first queue worker. Oh, typo. All right, there we go. We are listening to incoming jobs on this queue, and let's start up our dispatch command. Perfect, there we go. As you can see, this is the messages that we are receiving from Redis pub sub, and the queue is also showing the jobs that are going here. And there we go, it finished in around 12 seconds. So it took one queue worker to do all 100 of these jobs in 12 seconds. Let's see. What's going to happen when we introduce the second queue worker. So we'll dispatch it, and there we go. Here's the second one, the first one, and yeah, that's to be expected. We got two workers doing the same job. It's gonna be half time as fast. Of course, you could scale up these workers as much as you wanted, as much as you could on your computer or the network. Once you start them up, they will just stay there idly until they get a job. They don't waste a lot of memory. Depending on your application, they will probably just sit there idling, waiting for the job. That is something you will do in your deployment script. You will define where they will deploy and how many of them. And that's about it. I hope you learned something from this. If you wanted to learn more and wanted to try it out, you could always visit our GitHub, where you can find the whole framework and all set of documentation how to use it. It's under github.com/barrage/felony. And thank you very much for having me. Feel free to send your emails with questions. I'll be happy and I'll give my best to answer them and help you out. Have a good day.
Thank you for that, Tibor. And as I said, that does bring us to our first break. Don't go too far. We'll be back in about 5 minutes. Grab yourself a coffee, get yourself a drink, and we'll see you again soon. Thank you from us at Shift.
I love coming to Shift every year. First of all, Croatia is beautiful. What's really nice about Shift as a development conference is that it really brings people from all walks of development, and you don't really see that anymore.
The vibe here is incredible. There's such a buzz everywhere. I think 1,200 people turned up. I'm looking forward to the rest of today. There's a whole other day of conference tomorrow.
I'm often baffled by not how much I learn, but how I learn that I don't know yet. So I always go home from this sort of inspired, but also just very keen to just keep on reading up on stuff and learning what I evidently did not know.
Okay everyone, welcome back after our break. Let's hope you all had a good one wherever you are in the world. Hopefully you got some fresh air, grabbed yourself a drink. Maybe you were even thinking about some of the incredible speakers that we had before that break of ours. If you have had a good break, let us know. Give us a thumbs up there in that chat section. As ever, remember the hashtag for this event is #ShiftRemote. Please do be using that hashtag and taking photos, taking videos and posting about this on social media. Moving on after our break though, I would love to introduce our next speaker, who's a software developer and developer advocate from Lagos, Nigeria. They have a love for community building, open source and creating content and tech for the next billion years. I'm really excited to introduce Shedrack Akintayo.
Hello everybody, my name is Shedrack Akintayo and today I'm going to be talking to us about JavaScript build tools, past and beyond for Shift Remote Conference 2020. Thank you for coming to my talk. So let's quickly go in. So my name is Shedrack Akintayo, like I said, I'm a software developer, I'm a developer advocate, I'm a technical writer. So over the years, we've had to build our front-end code And there's certain reasons as to why we are building our front-end code, why the web in general is built. So we have reasons like dependency management. So we need to be able to manage all the dependencies our code needs without worrying about any of them breaking or not being available. So one of the reasons why the web is built is transpiling. So we need to be able to use the latest browser syntax of the language of JavaScript itself, without having to worry about browser compatibility issues. On bundling, we need to be able to get a production build, a very, very small and efficient production build for our code. And what's minifying, we need to be able to manage all our JavaScript code into smaller bits and even into a single file. So another reason is no module management built into browser. So certain browsers do not have management for modules. So we need to be able to use our JavaScript modules, mainly ESM modules, without worrying about browser compatibility issues. Next, so the story of building the web. So this is like an evolution of how we use several bundlers to build our code over the years. So in the years 2005 to 2010, this is where we saw the era of the first bundler. So Dojo was released as a cross-platform JavaScript framework for building cross-platform applications actually. So when Dojo was released, it came with its own builder called Dojo Builder that we built the code for Dojo code and transpiled it to also to the latest to the JavaScript that the browser could understand. In 2009, November 2009, JavaScript Google released a set of tools called the Google Dojo tools that had a library, JavaScript library, a standard JavaScript library. It had a web templating library. It also had a compiler called the Google Closure Tools compiler, Google Closure compiler in general, where it handles the removing dead code, linting of code, and all the whole things that the bundler is supposed to do. So, but these first bundlers, they had certain problems. They were not perfect. So for the Dojo Builder, it's heavy. Obviously, it relies on Java, so this makes it very, very heavy. It had a very, very poor documentation, so this affected the developer experience in general. So the user experience was so poor that people were looking for better alternative because they could not understand the documentation, and 90% of the time they had to figure out things on their own. Same with the Google Closure compiler. Of course, it belonged to Google. It was proprietary, and for an open source project to be proprietary, it means that people would not really consider using it, and it required Java, which makes it so heavy. Its compiling time is slow. Compiling time is slow, and it had a very poor developer experience. So this made it this first bundlers not perfect. They were really not perfect. Even though they were solving certain issues, but they were not solving most of the issues. So let's see how we go forward. So in the year 2010 and 2012, within this particular era, Gulp and Grunt came in. They were like game changers. They really changed the whole bundling game. So they were the first to try and standardize and also build usable pipelines on top of plugins. So this Gulp and Grunt gave developers flexibility to write their own script, to be the one in charge of their own building process. They also offered plugins, certain plugins that would help carry out basic tasks like maybe writing to a file, etc. So Gulp and Grunt were really the ones that brought the whole idea of plugins and also giving developers the flexibility to do whatever they want to do. So let's see Babel. So in 2012, Babel was released. Game changer, was really a big game changer because Babel was in handling transpiling in general. In general, transpiler, like I said, and Babel was handling transpiling in every single build that was coming at that point, even right up to now. So it converts ES6 syntax to common JS. So this is JavaScript that the browser can understand and use. It supports provided support for older browsers, Internet Explorer, etc. And it allowed developers to build custom plugins for their needs. So you could actually use a Babel plugin for whatever you need. Maybe you want to transpile, maybe Java, React code, etc. So there was certain plugins available for developers to use. So this enhanced the developer experience and made people continue to use Java Babel today. So to date, Babel is still in use, very much in use, and I don't think it's going anywhere anytime soon, unless a better alternative comes out, and we're not actually seeing any better alternative. So in the year 2012-2014, this is the era of browserify. it was a big game changer. Why? Because it had the power of npm package manager. Basically, it had the power of npm and also npm scripts. It provided developers with plugins for basic tasks. It uses the same Node.js syntax. It also used ES6 module syntax. So developers were like really enjoying Raspberry Pi, and it had solutions for most of their problems, and it was really good as at that time. So during the time, over the years, Raspberry Pi could not survive the growth of the JavaScript ecosystem, and that's where other build tools came in. So 2015 to now, Webpack was like a big game changer for the bundling ecosystem and JavaScript bundling ecosystem. Basically, it's faster than Raspberry Pi. It had its own personal server called the Webpack server, development server generally. It provided things like hot module replacements, where you really do not need to, your browser does not need to reload the entire page if the code changes in a single module. It only reloads that particular portion of the page, which was like mind blowing. Provided code splitting, which is a performance strategy for splitting your code into smaller bits when your JavaScript file becomes too much. It also provides live reloading. So whenever you change a particular file and you change a particular and you save it, it produces this live reloading. We also had the power of npm scripts where you could configure. So you really, at some point, you really do not have to have a config file for Webpack. You could just write every single thing we need, every single process we need to be run in it with power of npm script. We also provided plugins, so developers were like really flexing on plugins, in general, and they could like write plugins for themselves for whatever particular task they really want to carry out. So it also had presets like a collection of plugins. So it also had better developer experience than older build tools. I mean, the documentation was fantastic. It was bringing new features like hot module replacement, code splitting, live reloading, etc. So it was really good for developers at that time. Even right up to now, Webpack is still very much in use, and we are currently in Webpack version 5, and we are looking forward to seeing better things from Webpack. So the future. So what does the future look like? What are we expecting from build tools in the future generally? This is like the section where we talk about setting next generation build tools and the problem they are solving and what they bring to the table. So let's see the first one. So this is Rollup. So Rollup is a module bundler for JavaScript. It bundles all these JavaScript modules. It is easier to learn than Webpack. It had a faster build, like it's fast build, and it provides code splitting just like Webpack. And the configuration process. So one of the issues with Webpack at that time was the fact that setting up Webpack and configuring it was kind of a pain, and developers were looking for an easier means. So the creators of Rollup saw this as a means to outplay Webpack generally. So they made configuring Rollup way easier and less than Webpack. So when you are building a JavaScript library, Rollup is like the perfect build tool for building JavaScript library. So because of it's a module bundler in general, so it handles modules. So it has the power to combine small bit of code into one big file of code. So Rollup is like the best option for building libraries in JavaScript. So Parcel, when Parcel came out, Parcel's selling point was just install. You don't need to make any configuration. All you just have to do is npm install Parcel, and you are up to speed. It has a faster bundling time. It offers multi-core processing in general, and also plugins are not necessarily needed. Why? This is because the creators of Parcel sat down and thought about certain processes that they as developers needed to do when they are using build tools, and they made Parcel support all of this out of the box. So developers did not necessarily need plugins for most of their work, and it had an awesome developer experience. I mean, the docs are up to date, and give developers the flexibility to do whatever they want to do, and zero configuration. I mean, who doesn't love zero configuration, right? So Parcel was really a game changer when it came out. So let's look at the next one, Snowpack. So Snowpack is actually a very wonderful tool. Like I've been fascinated since Snowpack came out. It has support for out-of-the-box support for TypeScript, JSX, CSS modules, and other language and frameworks. So it's a faster build tool. I mean, the best part of Snowpack is the fact that it skips the bundling process in development. This is mainly because of its support for ESM imports. So ESM imports handles the JavaScript modules without while eliminating the bundling step. So you don't need to bundle anything during development. So the startup. So since there's no bundling, this made the development server very, very fast. Let's say at less than 50 milliseconds. It takes less than 50 milliseconds to start your Snowpack web server. Instant reviews on save. So I mean using fault module replacement, so you do not need to rebundle any single thing. Immediately you change any single file, it rebuilds it instantly without you having to worry about each rebundling any single thing. This is one of the major selling points of Snowpack, and I believe Snowpack Snowpack is currently in version 2, and I believe it has a bright future in the JavaScript ecosystem, and it's currently going to go far so far. So when version 2 was released, I think in last month or 2 months ago, I can't really put it down. Snowpack version 2 came with zero prototyping, out of the box zero prototyping. So you do not need to create a config file. It creates config files by itself out of the box. So you really do not need to create a config file by yourself really quick. So that's actually a game changer because it gives developers an awesome developer experience in general. So the documentation is also fantastic. Snowpack creators. I think Snowpack was created by Pika PKG. It's currently handled by Pika PKG and was created by Freddie K. Scott. Yeah, I mean, I hope I'm not pronouncing his name wrong, but then he is the creator of Snowpack, and they are constantly trying to improve the developer experience of Snowpack. So ES build, like this is a very, very fascinating build tool because it's actually still experimental. I think it was created by I think it's the CTO of Figma. I really cannot remember his name, but yeah, he's the creator. He is the main aim of ESB is to show that this is how fast, is to prove a point of how fast JavaScript build tools can be. Like it's insanely fast. The main selling point of ESB build is that it's insanely fast. I mean, it's written in Go. This is a language that compiles to native code, so they expect it to be fast. It's still very much experimental, and it's currently so far I cannot really I can't really say there's anybody using ESB in production. I mean, it's in the documentation, so there's currently nobody using ESB in production, but it's insanely fast. It's faster than Rollup, it's faster than Snowpack, it's faster than Parcel, it's also faster than Webpack. This is the main selling point of ESB, and ESB is looking bright so far, and I'm looking forward to seeing ESB finished project in general, to see the first release, the version 1 go live. So ESD server. So the funny thing about ESD server is it was created by OpenWC, Open Web Components, as a web server for development without bundling. So the funny thing is most of these build tools, these futuristic build tools, are actually using ESD server under the hood. So ESD server helps build these build tools to handle things like fault module replacement. Also handles things like bundling with just bundling in production only without skipping the development step, in the development. So also it also offered efficient browser caching for fast reloads. So if you need, so basically ES dev server, it's only a web server for development. So you can only use it for development. If you need to create a production build, you have to plug in something like Rollup or Webpack. So the ES dev server documentation advises developers to use Rollup for bundling for production. It also offers plugins, and it also provides TypeScript support without any extra tooling or plugs in. So TypeScript was actually supported out of the box because there's no bundling process in general. So currently, ES server is just only a development. It's a web server for development without building only. So it's like plug and play. You just plug in, install ES server, set your configs right, install your plugins, and you are good to go. It's also very fast. It also provides web caching, browser caching generally for fast reload. So it caches the entire file. When your web app is served with ESD server, it caches the entire file and will only reload if you change a particular file. So it does not change the entire file, it only changes that particular file that you change when you make a change. So that's one beautiful thing about ESD server. So Vite is a very, very good tool. It's still in version 1, I think. So it is created by Evan Yu, the creator of Vue.js. This is something that Vite was something that he thought about one night and basically wanted to just build. And so far it's looking like a very, very good build tool. It provides processes config out of the box. So you don't really need to download a plugin to apply processes. So every single view file, all these styles in the view script files, it automatically applies processes rules to it. So Vite provides first class support for Vue in the sense that the main aim of Vite is to create a bundler for Vue code. Basically, even though it supports JavaScript, JSX, TypeScript, etc., it still provides first class support for Vue, like providing instant hot module replacement for Vue and a more efficient build. But for production, if you need to create a production build, it uses Rollup for production build. So here's the funny thing. The difference, so you might say Vite looks like the same thing as Snowpark, it looks like Parcel, it looks like ESD server. There's certain overheads, there are certain differences between them. One of the differences, if you need a production build for Snowpark, you could just use a plugin. So there's a Webpack server plugin. There's also a Parcel server plugin, and all same for Rollup, but for Vite, use Rollup out of the box. Snowpark offers the development build to be as efficient as possible. So technically, you do not need a production build. You could still make use of a development build. But if you necessarily need a production build, you could just use a plugin like Webpack or Parcel. But Vite uses Rollup for only currently, as far as I know, use Rollup for the production build. So if you need a production build for your code, you automatically use this Rollup out of the box. So browser imports. So one of the reasons why the web is built as that how many years ago, about 10 years ago, is because of the browser could not support ES modules basically. But now on the new browsers we have, current Chrome, Firefox, etc., currently have support for I'm not sure if it's an entire support, but currently have support for modules, for ES modules. So one of the beautiful parts about using browser imports, like splitting your code and importing them into the browser as smaller modules, is that you can async or defer the modules in the script tag. So this is like a really, really good feature. It provides caching, and browser support obviously is not really that great yet, but Chrome has support. Chrome and Firefox, I think, have support for using ES modules directly in your browser. But this is actually going to stop the process of bundling. It's going to make delivery of code on the client side very, very fast. So browser imports is something that we're looking forward to seeing go bigger or be more supported in browsers like Safari, etc. So bundling free approaches, so runtime import system. So basically, most of these the futuristic bundlers currently use ES modules to skip the bundling processes in production, in development. So an example of a bundle free approach is Snowpark and also Vite. Not so much in UseDS, obviously. So they are currently not so much in UseDS because they are still it's still something that is in process, and not all browsers support ES modules. But if it's achieved, like an example is Snowpark. Lightning fast builds is going to provide features like lightning fast build and also lightning fast deploy time. So our code is going to be fast and it's going to be as efficient as possible. So in conclusion, in the future we'll be seeing tools like with zero configuration better customizability, so giving developers the ability to customize whatever they want in the bundlers, do certain tasks for them. We're seeing extensibility, ability to plug these build tools with other presets and plugins for better developer experience, and we're going to be seeing faster speeds from this bundler. So I mean, so in my opinion, choosing the right bundler is kind of what I would say is a trade-off. So it depends on the project you're working on and the requirements of that particular project. So there's no specific build tool that I would advise anybody to use. I would only say if you need to create a JavaScript library in this current era, I would advise you to use Rollup. Personally, I would advise you to use Rollup. But if you need to create a web application, this is entirely opinionated. If you need to create a web application currently, because of Webpack, it's currently still in use. So I advise you use Webpack, or for a web application, use Webpack, or you should use Parcel, or maybe Snowpack if you really want to get into the internals. But if you really are interested in building only a JavaScript library, I would advise you to use Rollup because it handles JavaScript modules better than most of the other bundlers. So choosing the right bundler depends on the requirements of the project you're working on, and it's something that you should really take your time in researching on and understanding what fits your needs. So if you need to understand most of these current browser bundlers, there are certain useful resources here and references that you could check out. Also, thank you so much for coming to my talk. This means a lot to me, and I hope you I hope you enjoy the rest of the conference. You can find me on Twitter at @Koda_Black if you really need to ask any question. You can also read my blog, which is also attached to the slides. Thank you so much once again, and have a nice day, and also enjoy the rest of the conference. Thank you.
Thank you so much for that talk there, Shedrack. And hopefully we're taking some real gems from this conference so far. Let us know what you've already got bubbling under that surface there of yours. Moving on though, our next speaker wrote their first line of code at the age of just 12 on their father's old i386. Since then, they've never stopped coding and currently work at FabFitFun as a principal software engineer, where they're building microservices to serve millions of users every day. They're the co-author of Node.js design patterns, and they run the Full Stack Bulletin, which is a newsletter for full stack developers. I'm sure we're about to find out a lot more from the man himself. It's Luciano Mamino.
Good morning, everyone, and thank you, Bilal, for the lovely introduction. Welcome to this talk called Node.js Scalability Tips. My name is Luciano, and I work as a principal software engineer at a company called FabFitFun in Dublin, Ireland. One of the things that I am most proud about is being the co-author of this book called Node.js Design Patterns, which is actually very relevant for this talk. The third edition has just been announced. It's not ready yet, but you can already pre-order it, and it should be around in a couple of weeks. So please follow me on social networks if you want to be updated on the latest news. So before we get started, I want to mention that I already have the slides available online, so you can either scan this QR code or go on the link below. And this is very important because I'm going to be linking a number of interesting links where you can get more details about what I'm talking about. So I really recommend you to get the slides. So at the end of the talk, you can get the additional material. Okay, so Node.js and scalability. Very interesting and absolutely broad topic. And it's such a broad topic that in the book I mentioned before, we actually covered 2 chapters and it's more than 100 pages. So when I wanted to prepare this presentation, I was a little bit confused. How can I talk extensively about this topic in just 20, 30 minutes? So I went on Twitter and I asked my developer's friend, when I say Node.js and scalability, what do you actually think? What are the first ideas or challenges that come to your mind? And I got a bunch of very interesting answers. So Matteo, for instance, mentioned caching, head-of-line blocking, number of file descriptors, promises, bad code. Luca mentioned design and right supporting architecture, so great focus on architecture. Also, a lot of common developer problems like spaghetti code, refactoring due to the lack of type safety, attitude around testing, and other issues like understanding the event loop and debugging the event loop, and the list goes on. We have, again, scalability, but also maintainability and performance, memory leaks, caching again, and finally, my favorite one, arguments with Java people. But that, of course, was a joke, right? Okay, let's talk about the classic definition of scalability for Wikipedia. Wikipedia defines scalability as the property of a system to handle a growing amount of work by adding resources to the system. But actually, there is even a better definition, in my opinion, and it comes from Werner Vogels, the CTO of AWS. And he says, a service is said to be scalable if, when we increase the resources in a system, it results in increased performance in a manner proportional to the resources added. So Werner makes a point of performance being proportional to the amount of resources that have been added to the system. So this is really important. I think this is critical to understand that a system is scalable only when you can control the growth in performance just by adding resources. All right, let's start from a few very practical tips. Tip number one is establish a baseline. What do we mean by that? Let's take, for instance, a sample application. I created this very simple web application. You basically can pass data to query string parameters, and basically you can call this endpoint, and you will get a QR code representing that data as an output to your request. And this very simple application is already online. You can click the link below, and you will be able to see the code and run it and play with it. But let's have a look at the code first. The code is super simple. It's an HTTP server. We can use the standard Node.js HTTP server. Then we use the URL module, and we import an external library called QR code. Then we create our server, and in the under function, the only thing that we do is we pass the URL of the current request. We get the data parameter from the query string parameters. And then, of course, if there is no data, we return a 400 because this is not a valid request. Instead, if there is data, what we do? We are going to start to write the head response saying this is going to be an image PNG, and then we use the QR code library to render the PNG for the current data and return it to the user. So super simple stuff. How do we know if this code is performant? Well, there are a number of ways to determine that, but being this an HTTP server, one of the most common ways is just to use an external tool to run the server and bombard it with requests. And then we will collect a number of statistics, and we will be able to determine, is this fast enough? Is there room for improvement? Two of the tools that I like the most are AutoCannon, which is actually written in Node.js, so it's very, very easy to use in the Node.js ecosystem, or WRK, which is actually more generic, so probably you have seen it also coming from other languages. Now, if we want to use AutoCannon as an example, this is how you can run it. With this specific command, we will be running our server and then create 200 connections in parallel, and we're going to start to bombard this specific endpoint that is creating the QR code for the data LO shift. And when we run this on my machine, this is more or less the result that we get. We get a latency of almost 2 seconds, an average number of requests per second of about 100, and 168 kilobytes per second. Now, these numbers instinctively are probably good, but at the same time, we might feel that there is room for improvement. 100 requests per second is not a lot, so maybe we could see if there is any chance to improve this performance. But how do we do that? We'll get that in a second. But before, I want to show you an additional tip. How do I know that maybe there is room for improvement? And one thing that I really like to do is basically to create a super simple HTTP server that just does an hello world. And basically, I benchmark the same server in my machine so that I can get numbers that I can use to compare with my previous results. So if we run autocannon on this super simple hello world server, we'll get these very interesting numbers. 2 milliseconds of latency, almost 34,000 requests per second, and a lot more bytes per second being transferred. So you can see that Node.js in itself, if you just take the bare overhead of the HTTP framework and the streaming abstraction, it's very, very fast. So this can make us think, okay, my server is not fast. Of course, it's doing a lot more stuff than just saying hello world, but maybe there are chances to improve the performance because I'm not constrained by Node.js or my machine. Okay, let's move to the second tip. Find your bottleneck. Now we know that there might be room for improvement. Where do we start looking for improvement, right? There are a number of techniques to do that, a number of tools. I just want to introduce one that is probably my favorite, and it's called Clinic.js. Now, I'm not going to show you a demo. I actually recommend you to go to the website. There is an amazing demo by Matteo Collina that will show you how to use this tool for a real troubleshooting and for a real performance improvement of an application. But I just want to introduce what are the main tools in Clinic.js. The first tool is called Clinic Doctor, and it works very similarly to autocannon. It actually uses autocannon behind the scene. And what it does while it's running an autocannon benchmark is also going to collect a number of useful metrics. For instance, what is the CPU usage? Are there any meaningful delays in the event loop? How much memory is the process consuming? And how many file system handles are active at a certain point in time? And what's even more interesting is that at the end of the benchmark, you will get this dashboard, but also the benchmark will analyze this data and will provide you meaningful insights and observation. For instance, here the doctor tool has figured out, well, the memory usage is not great. Maybe there is room for improvement. Also, I've seen a lot of event loop delays, so most likely you are doing a synchronous operation that is taking a long time and is blocking the event loop. So these are pointers that can help you out to figure out how to improve the application. Now, Clinic also offers other tools. Another one is Flame, which allows you to create flame charts. Very similar approach. It's going to run autocannon behind the scene. It's going to collect data. And with a flame chart, if you have never seen one, what basically you can see is that given all the functional calls in your code, including dependencies, you will see where the code is spending the most time. For instance, in this application, we can see that the hottest point is basically this function called filter_sum patch. And basically, this comes from a dependency, PNG.js, that is probably a dependency of our QR code library. Now, I actually haven't checked, but the first thing that comes to my mind is, okay, maybe this library is written in JavaScript. Maybe we can use a native library written in C or C++ to make this go faster. So this is just another pointer that you might get if you want to invest time in trying to improve the performance. And Flame chart can help you to actually figure out where you can get the most benefits in improving performance. Now, the last tool I want to present from the Clinic suite is Bubble. And Bubble is a very new way to present asynchronous code. So it's going to help you to understand how the different asynchronous calls are related to each other. And again, where the application is consuming most of the execution time. So this is just another way to try to visualize, understand your code, and find other places that can be a source of slowing down or that can be just improved. Okay, tip number 3, understand your goals. So now we have our application, we know how to run benchmarks, we know how to get some indication on what can be worth improving, but what do we actually want to improve? And what do I mean by that is maybe you want to increase just the number of requests per second, maybe you want to reduce the memory footprint because you have an environment that is very constrained in terms of memory, or maybe you just care about latency because you want the user to receive an answer as soon as possible. Now, it's very important to understand on which dimension you want to optimize for, because most often optimizing for one might have a negative impact on another. For instance, if we want to optimize for throughput, it's very common to introduce a caching layer, which means that probably you're going to store a lot more data in memory, therefore the memory is going to increase. But that data is something that is pre-calculated and is going to help you out to respond as quickly as possible. So On one side, you're going to improve throughput. On the other side, you're going to make memory a little bit worse. So just make sure that you understand what are your goals, because probably you cannot get a win on everything. Okay, tip number 4, always observe. And by that, I mean in production. So far, we have been focusing on, we have a piece of code, we run it on our machine, we get some numbers, we try to do some changes and make sure these numbers will become actually better. Now, this is all great, but in real life, your tests are not going to reflect what is going to happen in production. So it is very important that you also try to collect as much data as possible from your applications running in production. And generally, when we talk about collecting data in production, we talk about logs, metrics, and traces. Of course, you probably know logs. And the point there is that you should be able to write logs that will give you a good indication on whether your application is working well or whether you have some problem, and the log should be indicative enough to make you understand where to look for more data to understand the problem. Metrics allow you to collect data such as the CPU consumption over time, memory allocation, but also custom metrics like how many users are currently connected to the website, how many users are logged in, how many users have purchased a specific product. So metrics will give you an indication on people, how people use the application over time, but also how the system reacts over time in terms of CPU, memory, and other important metrics. Traces is a very important concept, probably the one that is the least used, I would say, but it comes very, very handy, especially with distributed systems. It's very similar to the flame chart we saw before, but instead of working only for a specific process, it works across distributed systems. For instance, if we have an application that is going to call an external API and then it's going to call a database, using traces, you can actually visualize the time spent in these 3 different systems. And therefore, you can determine in which of these 3 systems is more important to start to think about optimizations. Now, here I have presented a number of open source technologies that you might be using for logs, measures, and traces, but there is no shortage of even paid technology that you can just buy and use as a SaaS service. So make sure you just check them out and pick the ones that are more suitable for you. All right, now let's come to the final and probably the most important tip: scale your architecture. So far we have been talking more about performance rather than scalability. And the 2 things, while they are related, they are not exactly the same thing. Because we say that scalability is basically adding resources to a system to make the entire system more performant, the entire application more performant. But so far we have been focusing on something in isolation that runs on our machine, and we try to make it faster. This is not really scalability, that's more performance. The scalability comes into play when you try to think, okay, I'm not gonna necessarily change my code, but I'm gonna change the architecture, and I'm gonna make sure that I can scale as much as I need to. So there is no limit. How do we talk about scalability? One of the tools that I like the most is the scale cube. And this concept was introduced in this book called The Art of Scalability. It's not the newest book. It has been around for a while, but it's impressive how actually is today you can use all this learning without any change. So the theory hasn't changed in the last 10 years probably. Now, The Art of Scalability introduces the scale cube to explain 3 different techniques that you can use to scale an application indefinitely. And they use the 3 axes of the cube to present these techniques. On the x-axis, we have the cloning technique. On the y-axis, we have the functional decomposition technique. And on the z-axis, we have partitioning. Let's try to explain all of them and try to understand why they are important. So on the x-axis, we have cloning. And cloning is basically the idea that if you have an application, let's think again about our QR code example, and that application is running in one machine, you can just take the same application and run it multiple times and then just distribute the load from your user to different instances of that application. Now, in Node.js, this is particularly interesting because if you know Node.js, you know that it's said to be single-threaded environment, which basically means that most of the code runs on a single thread. And therefore, you are probably not taking advantage of all the resources available in a machine, especially if that's a multi-core machine, right? So what you can do is, even in the context of a single server, you can use this technique to try to exploit all the resources available in the machine. And basically, the idea is what we see here on the left side of the slide, that you can take the Node.js process for your HTTP server and run it multiple times in the same machine, and then just distribute the load of requests across all the different available instances. Of course, the classic incarnation of this pattern is basically to do that by replicating the entire machine multiple times and have a load balancer in front of all the machines available. Now, in Node.js, how can we replicate the process? Again, let's think about our QR code server. And there is a module that is actually built in the standard library of Node.js that is called the cluster module that makes very, very simple to do this replication. So the idea behind this module is that there is going to be a master process, and then there will be a number of worker processes. Now, the master process is going to listen for incoming requests, and as soon as they arrive, it's going to start to distribute them across all the available workers. How can we implement this in a generic HTTP application? Let's see some code. It's super simple. You just need to require the cluster module. Now, here we would like to basically run as many worker processes as the number of codes available in the machine, so we can use the OS module to get that information from the current system. And then there is this very classic if statement that you might be used to if you come, for instance, from the C background and you have been using threads. It is actually mimicking the same pattern. So in the first branch, we have a check whether this is the master node or the worker node. And if this is the master node, the only thing we have to do is to call cluster.for for a number of times that is equivalent to the number of codes available in the system. Every time we run for, basically the same code we have here is going to run again in another process, but this time we are going to end up in the else part of the branch, the worker code. And this is literally where you have to specify the HTTP server functionality that you want to implement. In this case, since we already implemented it, we can just require the file that implements our QR code server. So this is super simple. And what's great about this is that by doing only this wrapping in my machine, which is an 8-core machine, the performance, the throughput has increased between 3 and 4 times. And this is literally no change in the code. It's just an extra layer of wrapping. Now, this is not the only way to do this. Actually, Node.js, since the last few releases, supports this concept of worker threads, which essentially, if the cluster module is using processes with worker threads, you can actually create threads. So you can also share memory across the different threads. So, and also you have a lot more flexibility on how the data is distributed and the load is distributed across these different threads. There is a new library that is very, very interesting. It's called Piscina, so check it out. And this library also showcases you how to do this HTTP load balancing across different threads. So maybe this is another approach that is definitely worth exploring. Now, cloning is probably the easiest strategy to scale a service because it doesn't require a lot of changes in the code. But you have to be careful because this is true only if your application is stateless. What do we mean by stateless? Let's take a very classic example, user login. What do we do with user login? Generally, we have a form where the user is inserting username and password. We check that information against a database. Then if the information is correct, we create a session cookie, and then we store a mapping saying, whenever you see the session cookie, this is actually the user that logged in for that session. And sometimes this information is stored directly in memory inside the process. And in that case, our application is stateful. What does it mean? That if we end up the next request in another process, we are not going to have the information for that session. So the user session is going to be invalidated and the user is going to be logged out. So let's just be aware every time you use the cloning technique that you don't keep any data, any shared data locally. And you need to be conscious that your user might be ending up in different servers or processes for every single request. So if you have this kind of situation, make sure you put the state somewhere else externally, maybe a Redis instance, so that every single Node.js process can get the information every single time. Now let's move to the second scalability technique, functional decomposition. This is generally the y-axis. Now, functional decomposition is mostly well known as microservices, and it's basically the idea that rather than building a single application that does everything, maybe it makes sense to split a big application into a number of independent sub-applications. For instance, if we were building an e-commerce, probably it would make sense to have a products application where we store all the products and the search and the catalog and the attributes of every single product. And then maybe we can create another application that manages the cart. So users adding things in their own cart and maybe starting a checkout from that cart. And in the case that we are building just API services, maybe we can use an API gateway to coordinate the access to all the different services. Now, this technique, you have probably seen it before. What is very interesting, in my opinion, is that you can combine this technique with cloning. For instance, if products is going to start to get a lot more requests per second, you can spin up a new instance, and cart the same. Maybe you can spin up even 3 instances if you need to. So the idea here is that those techniques, they are not supposed to be used in isolation, but you can actually combine all of them to achieve even more scalability. Now, Node.js is a great fit for microservices, in my opinion, and the reason why I say that is because the whole Node.js ecosystem was built with the mindset of building something small that does one thing very, very well and can be easily integrated with other systems and libraries. So if you use Node.js for microservices, you will see that the entire ecosystem is naturally fitting that mental model. So I do really recommend, if you're building microservices, to consider Node.js for that. Now, another interesting detail about microservices is that they allow you to scale your architecture, but not just your architecture. They can have a massive positive impact also in scaling your organization. And this is just for a very simple reason. If you have different services, you can take different teams and make them responsible or give them the ownership of different services. That basically means that different teams, they will not wait for each other to ship a new feature. They will not have to step into each other's code to decide where to work on or how to deploy a change. So I think when a company is scaling and you are hiring very, very rapidly, microservices will actually give you a greater benefit on scaling the organization rather than the benefit you will get on scaling the architecture. So make sure you understand these dynamics as well, because they are very important and they will be determining the success of your microservices architecture. Now, microservices are not free of charge. They definitely add complexity, so also make sure that you use them only when you really need to use them. And just to give you a few examples, when you build microservices, you will have a very complicated distributed system, a number of different apps doing different things, and every app can be replicated or cloned a number of times, right? So how do we do observability? Like, how do we collect all these logs and metrics and traces in a consistent way? How can we query all this data in a way that is meaningful, that we can collect all these different data points and make sense of them? But also deployments, how can we make sure that doing a deployment of a new service is not going to break existing services that maybe depends on this one? And that's very closely correlated with versioning and integration. So once you start to use microservices, you need to build an entire infrastructure that can support your microservices deployment. So make sure you do that work up front and you understand all the challenges. Now let's go and talk about the last technique, partitioning. So partitioning is generally used to scale databases. And the idea is that we are not going to change our application. We are going to have multiple instances of the same application and make sure that those instances can access different subset of the data. For instance, in our e-commerce example, we might split the product catalog in two, and we might decide to divide these products. For instance, if we have an ID, we can say okay, all the products which ID starts with a letter from A to L will go in database 1, and all the others will go in database 2. This is called shard partitioning, and it's basically used to scale databases because it will allow you to create as many databases as you need to. And of course, it's not free as well, because you will have the extra complexity of routing the traffic to the right database and aggregating data maybe coming from different databases. But the point is that at some point, if your database doesn't scale anymore, you will need to use a technique like this to make sure you can keep growing your architecture. Now, this technique is also used by SaaS companies to distribute their software geographically. For instance, if you ever use something like Datadog, once you log in, they will ask you, do you want to use the European region or do you want to use the United States region? And depending on your choice, you will have a different domain, and probably they will have built behind the scene an entire replicator infrastructure with different databases. And basically, you will not, if you go in the European geographic zone, for instance, you are not going to overload the American geographic zone. Also, you will probably have a better latency if you're actually based in Europe. So this technique is probably the least used of the three, but is the one that will give you the most scalability boost when you start to hit your limits. Okay, so just to summarize all my tips, the first one is establish a baseline. So make sure you don't just try to optimize randomly, but you know where you are starting. So every time you change something, you can measure again and see if there was actually an improvement and how important was that improvement. Then you need to know a number of techniques and tools to be able to find your bottlenecks. Again, don't just try to optimize random things and hope that they will make a difference. It's much better to invest your time in figuring out where are your bottlenecks and then trying to optimize for those bottlenecks first. Then understand your goals and understand that sometimes you cannot just optimize for everything. So you have to pick one battle and maybe compromise on other battles to make sure you get the best outcome on that specific front. Finally, always observe. So don't just do these tests in isolation in your machines, but make sure you always collect data in production, because only in production you are going to discover what is actually important for your user, what are the patterns that people actually create with your application. And probably you will figure out different places where you need to optimize your application that you wouldn't have figured out on your own machine. And the last tip is scale your architecture. So understand the cloning, the decomposition, and the partitioning technique, and make sure that you can use them not just in isolation, but also combine them to achieve even greater scalability. And that concludes my talk. So thank you very much for listening. Again, you can get the slides at that link. And if you have any question, I will be available on the chat. So feel free to write your question there, and I will answer you as soon as possible. Thank you very much.
Thank you for that, Luciano. And with that, that brings us almost to the end of our third Shift Remote. If you've had a good time so far, let us know. Give us an emoji, give us a thumbs up, give us some words there in that chat section, because we're really sad to be coming to the end here today, but one man separates us from that. And they're originally from Krapina, graduated from the Faculty of Electric Engineering and Computing in 2017, and have started their own professional career at Infinuum as a JavaScript engineer. After practicing some dark Angular magic for a while, he moved on to become the lead Angular engineer. His main interests are gaming, web development, mechanical keyboards, and this is why I love him, and being cynical. Let's introduce Filip Voska.
Hello everyone, my name is Filip Voska. I am lead Angular engineer at Infinuum, and today I will be talking to you about coding Visual Studio Code extensions, or rather, since we only have 10 minutes, we will only be getting started with coding Visual Studio Code extensions. So what is Visual Studio Code? It's a really popular open source text editor. It's available on multiple platforms like Mac, Windows, and Linux. It is highly customizable via extensions, and it is built in TypeScript and runs in Electron. This part is important because we will also be building our extensions in TypeScript. So what are extensions? You only have to look at the Visual Studio Code extensions marketplace to get an idea of what's possible with extensions. This could be anything from adding support for new programming languages and file types, adding custom components and views in the UI, display a web view with a custom interactive web page, change the look and feel of the editor, help with debugging a specific runtime, and also help you automate boring tasks. So how do you get started with coding Visual Studio Code extensions? So you could use some kind of a code generator, right, like Yeoman. I'm not sure how this is pronounced, but basically this command will ask you a couple of questions about your project, which is extension name, what type of extension it is, and so forth. Once you run through the wizard, you can open your project and you will see that there's a bunch of files generated and you can start coding. So first, let's just try running our extension. So you can go to the debug menu of Visual Studio Code, hit run, and it will fire up a new instance of VS Code, which has your extension installed. So here you can play with your extension and debug it. So we can, for example, add a breakpoint in our extension, run the instance of the editor, and when we hit the command, we can see that the debugger stops and we have our call stack. So this is really useful and powerful for debugging your extension. When we look at the generated project files, our main file is extension.ts. This file imports Visual Studio Code from Visual Studio Code package. This is what is available in VS Code runtime, and it has to export activate function. It can also optionally export deactivate function. So deactivate function, you can do some cleanup work here when you close the editor, and the activation function will be called when your extension gets activated. So let's first take a look at when can your extension get activated. There are multiple activation events which can trigger. Some of the main ones are on language, which will activate your extension when you open some file in a particular programming language. One other popular one is on command, which will activate your extension when you explicitly run some command. There is also asterisk activation event, which will activate your extension when you run the editor. So you probably don't want to do this, so a choice of activation event is important. It is also important to list your activation events in package.json file of your extension. So let's take a look at our contribution point in our Hello World extension. So our activation event will just log some message to the console. We will be able to see this in your editor. And we have our first contribution point here. It is a command which is named duckify.helloworld, and all it does, it shows a toast message with some text. So these are all the possible contribution points, and we will only really be showing you today the commands contribution point. But as you can see, this gives you a good idea what's possible with extension. It has everything from themes, grammars, languages, debuggers, commands, menus, views, all sorts of things. And also contribution points have to be listed in your package.json file. Here you will name your commands. So in my editor, when I'm running the extension, the command duckify.helloworld will have title hello world. So let's take a look at a quick example how we can create something that's actually useful, which could help us. So what we will create is an extension for which you can select some text, hit command turn into ducks. It will then prompt you for some word, and when you hit enter, it will replace all the occurrences of entered word with duck. So here I selected all the text, entered swan, and it replaced all occurrences of word swan with word duck. So nothing too smart, and let's take a look at how we can create this. So this is all the code which we have, and we will go through it line by line. So first we register our command. We will name it duckify.turnintoDucks. Now we have a handler function which will get called when we run the command. First, what we want to do is get an instance of the active text editor. And if there is no active text editor, for whatever reason, we will just stop here, return nothing. Next, our extension works with the selection of text. So editor has property selection, which we can get. It's basically a cursor with beginning and an end. And for that selection, we can get from the editor document the text which is selected. Now, this is a really nice part of the API. Everything is promise-based, so we can await the user action. So we await the answer of the input box. So here we can enter text for the prompt. Which word would you like to replace with duck? We have some placeholder text, and now we just await the result of that action. Once we have the result, we can get the text of the selection and do some simple regular expression replacement of that text. We'll replace whatever the user entered with the word duck. And finally, once we have our changed text, we can call the method .edit on the editor, and in the callback itself, we can call the text editor edit replace method. And this is basically all there is to it. It's really simple to automate some maybe boring tasks which you have. I have used this on some of my projects to automate generation of some enums based on some lists. So as you can see, it's easy to get started, and I encourage you to try it. When it comes to publishing extensions, yes, you can do it. It's free, but you will also have to create a Microsoft Marketplace account, which maybe some people don't want to do. If you don't want to do that, you can also package your extension just into a file. You don't have to publish it. Maybe it's some extension for your own personal use, and you can just install this file when you want. You don't have to publish it. Here are some of the resources. As you can see, only things I have listed is the official documentation, because it is really, really nicely written, and it is basically all you need to get started. Thank you, that has been all. Please post any questions in the chat, and I guess I will see you guys sometime again. Thank you. Bye.
Thank you so much, Philip, for wrapping up our Shift Remote Part 3. Thank you to everyone who's been listening. Hopefully you've stayed engaged with us. Let us know what you thought, right? We're always sad at the end of these conferences to see you go without having an after party. Have a party for yourself wherever you are. And hopefully you'll join us again. Our next one is on the 14th. If you haven't registered yet, there's information available on our website, which I encourage you to check out and find out more. All that's left to be said from us here at Shift is thank you to our sponsors. Once again, the team at Microsoft, Infobip, Autodesk, Microblink, Barrage, Azure Idea, ICT, Japania, Venture, Pseudocode, 9 Dots, 5, Ars Futura, Infinium, Q, Get by Bus, Aspira, Code Anywhere, Pluggy, and Netokrasia. Without you, this wouldn't have been possible, so thank you to you all. Thank you from us here at Shift, and we look forward to seeing you again. Goodbye.